We will be solving Mindflayers curse. So let's take a look at the problem statement. During a late night Hellfire Club Dungeons and Dragons session, the kids in Hawkins discover that their game board has been corrupted by the Mindflayer. The board is an 8x8 grid where each cell is either light or dark, represented by characters W and B. The Mindflayer thrives on chaos, and as a result, some of the rows of the board have lost their proper pattern. In a true Hellfire Club game, the board must follow ancient rules. No two adjacent cells can share a side that have the same color, and the top left cell must be light. To counter the Mindflayer's influence, the Dungeon Master allows a special move. Any row of the board can be cyclically shifted. A cyclic shift moves the rightmost cell of the row to the first position, while all other cells shift one step to the right. The spell can be cast any number of times on any row or not used at all. Your mission is to determine whether the Hellfire board can be restored to a valid configuration before the Mindflayer breaks through Hawkins. So, the input format. The input consists of exactly 8 lines. Each line consists exactly 8 characters, either W or B with no spaces. The jth character in the ith line represents the cell at row I and column J. Constraints. The board size is fixed at 8x8. Each cell is either W or B, and at least one valid neighbor exists for every cell. Output format. Print yes if the board can be restored to a valid Hellfire Club board, otherwise print no. Sample input. So this is the target configuration of a valid Hellfire board. It follows the chessboard rule, meaning no adjacent cells share the same color, and the top left cell is white, which fixes the entire pattern of the board. Now, on observing any row of the board, we notice that it must alternate between white and black. So there's only two possible ways that a row can look, pattern A and pattern B. Pattern A starts with white and alternates between white and black, and pattern B starts with black and alternates between black and white. No other row pattern can exist in a valid Hellfire board because any repetition would violate the adjacency rule. Now, the problem allows a special operation called a cyclic shift on any row. A cyclic shift moves the last cell of the row to the front and shifts all the other cells to the right. So when I apply cyclic shift to the first pattern, it becomes the second valid pattern. And when I apply another shift, it goes back to the original pattern. So a cyclic shift can never create a new pattern. It only switches between the two valid patterns. So if a row is not already pattern A, it has to be pattern B, else no number of cyclic shifts can make it valid. So instead of performing cyclic shifts, we can just check if each row is already matching one of these two patterns. If it doesn't match, then we can immediately say that the board cannot be restored. So checking the row individually is not enough. We must also check the rows vertically to avoid the same colored adjacent cells. So that's why the board must contain 4 rows of the first pattern and 4 rows of the second pattern for proper alternation up, down, and left and right. So taking a look at the code, we start with the main function. We take the input in the form of a string, call it row, and these are your two predefined patterns, pattern A and pattern B. We also set a counter for A and B and set it to 0. Now we run a loop. So from int I is equal to 0 to I is less than 8, I plus plus, we input the row. Then we check if the pattern of the row is equivalent to pattern A, we will increase the count of A. Else, if the pattern of a row is equal to pattern B, we will increase the count of B. However, if it doesn't match A or B, we will just return no. Then we check if the count of A is equal to 4 and the count of B is equal to 4, we will print yes, else we'll print no. So on running the code, we see that the sample test case was a valid Hellfire Club board, hence your output is yes. Then we submit it. And it passes all the test cases. Thank you.